Hello everybody, and thank you for joining us today for the latest webinar in our Vertica Data Disruptor series. In this series, we highlight the many ways that our customers and partners are using data to disrupt certain businesses, industries, and processes. Today's webinar is entitled Vertica in EON Mode, running natively in Kubernetes. Now, my name is Paige Roberts. I'm the Open Source Relations Manager at Vertica, and I'll be hosting today's event. Joining me is Jan Sobusta, Senior Principal Software Engineer at GoodData. Before we begin, I'd like to encourage you guys to go ahead and submit your questions or comments during the event as they occur to you. Just type your question or comment in the question box below the slides and click Send Question. We do have a Q&A session at the end of the event, and we'll answer as many questions as we're able to during that time. But you don't have to wait until the end. Go ahead and enter your questions right along as we go along. So let's see here. We have, just as a reminder, you can maximize your screen by clicking the double arrow button in the lower right corner of the slides. And also, this webinar is being recorded, so before you ask, it will be available to view on demand later today, along with a PDF copy of the slides. So I'll go first, and then I'll turn it over to Jan in just a few minutes. We're going to do, first I'll do a little quick bit on what Vertica is, and then Jan will take over, and he's going to talk about who he is, what is GoodData, the history of how Vertica is, and GoodData have worked together, and then the changing requirements, the new features that they need to meet their new requirements, and what solution he's come up with. And he's even going to do a demo for you guys today, so that's kind of cool. And then talk about where we're taking it in the future before jumping to the questions. So that's the plan. So let's start with, what is Vertica? Now, this is kind of level setting for anybody who doesn't know Vertica already. Just pretty much what the heck are we? We are a unified analytics warehouse, which means we combine a lot of the capabilities of a data warehouse and a data lake. And we're built for the scale and complexity that you face. It's a high-performance MPP query engine with advanced analytics and machine learning built in. So a lot of people know us by one particular aspect of what we do. So yes, we are a SQL database that is also often used as a data warehouse, which means we have a really fast analytics capability. We can drive your BI dashboards. We're great for ad hoc queries, all the kind of things that you sort of come to expect from a data warehouse. Now, we have also built in a great deal of the more advanced analytics capability that you tend to think of as in a data lake. Things like machine learning and geospatial and time series analytics. We have the capability to prep data for data analytics, find things like outliers and correlations, and a lot of the sort of things that you tend to think of as data lake sort of things we do inside our database. And we also can handle a lot of the kinds of data that you're used to thinking of in that way, like JSON and Avro and Parquet and Orc, things like that. We can query them, read them, write them, that sort of thing. So that kind of gives you the idea. And plus, we also have the capability to split off our query engine and go off and query things on a Hadoop cluster, if you would like to do that separately or as part of the database itself. So this one of the things that we like to say is that the important thing about this slide is not the things on it, but the big plus signs, because there are a lot of things out there that do one of those things or another of those things, but we do them all, and that's what Vertica is all about, is giving you a lot of flexibility to do that on-premise, on the cloud, wherever you'd like to do that. Now, we have a lot of really great customers that are doing some pretty amazing things with Vertica right now. We have a free community edition that can handle up to 1 terabyte, so you can start as small as you want, and then we can scale up as large as you want. So Uber is, handling 100 petabytes, and the trade desk has over 15 petabytes of data on the cloud, and we can do that, or we can do sub-second response for some of our other customers. And we are in a lot of different industries, from software optimization with TurboTax and Intuit, to healthcare optimization with Cerner, to marketing optimization with Criteo, that kind of thing. So we're kind of all over the place, and a lot of times you use us and don't even realize it, because we are embedded in a lot of really cool analytics capabilities like GoodData. So with that, I'd like to hand it over to Jan, and he's actually going to share his screen so that he can do the demo when he gets to it. So go, Jan.
Hello, thanks for the introduction. I am going to share my screen. Okay. Okay, so my name is Jan Soubusta. As I have already introduced by Paige, I am a Senior Principal Software Engineer at GoodData. I've been in GoodData for the last 6 years. Most of the time I was focused on databases and especially on Vertica. But in the last a year and a half, I moved to the team responsible for delivering completely new GoodData platform. So I represent GoodData. Our current or recent motto is analytics everywhere for everyone, which relates to this presentation, and it's not a coincidence. So what are GoodData use cases? So our end users make decisions based on insights. Those insights are embedded into and can be even controlled by their applications. Users can also consume interactive dashboards, and even they can create their own insights and dashboards. The second use case relates to data engineers and analysts who are responsible for building logical model on top of the physical data model. And then they build measures, insights, and dashboards, which then can be used by the end users. Additionally, we also provide SDK, so even developers can build their own React applications and embed insights into them. What are the key differentiators of GoodData? First of all, there is strong support for developers. We provide REST API almost for everything, and we also provide UI SDK, so developers can build their own data applications. We provide logical modeling, so you can decouple the logical view from the physical view, and you can easily absorb any changes in physical model. We also provide our own analytical language, which is called MACL, and it's much easier than, for example, SQL. Yeah, so you can build even quite complex measures using very simple language. The additional differentiator is also distribution. Our typical customer is another software company, and they need to distribute analytics to their customers, and this is definitely the use case for GoodData. Users can also collaborate, so they can share insights and so on. We also provide end-to-end data pipeline because we have data warehouse as a service. And last but not least, we also provide security shield, which is compliant with SOC 2, HIPAA, GDPR, and so on. Okay, so now let's dig into the GoodData history, specifically how we used and how we have used Vertica. So why we decided to use Vertica? So first of all, it's shared nothing architecture. So there is no single point of failure, and there is no need to manage multiple components, like, for example, in case of a Hadoop. It provides best performance for analytical or ad hoc queries. It provides low latency and also high throughput. And last but not least, it can be scaled horizontally. We use Vertica in two major use cases, in data warehouses and in so-called data marts. In data warehouses, we deploy clusters. We provide multi-tenancy, so multiple customers can share the same cluster. And a typical use case there is ETL. We have our own GoodData data pipeline, so customers can easily implement their ETL. We have more than 150 connectors, so customers can download data from almost everywhere. The second use case are data marts. There are only single nodes as of now. Again, there is multi-tenancy implemented, and it serves on ad hoc analytics. SQLs are generated by GoodData algebraic query engine from already mentioned Macro language. Okay, so 5 years ago in the beginning, there was only one data center. We have our own private cloud. There are just few customers, circa 10 Vertica databases. The biggest cluster had 4 nodes, and we provided almost no SLAs. After 5 years, we have 4 data centers on 2 continents. We have a lot of customers, over 100 Vertica databases and over 250 Vertica nodes. The biggest cluster has 54 nodes, and we have to provide SLAs at least 99.5%. So as you can imagine, there is a threat. So how we are able to manage something like this? So in last 5 years, we had to implement a lot of automation. You can see some logos here. We implemented a lot of jobs in Rundeck and recently in Ansible. We also delivered service discovery. So anytime you can see what Vertica nodes are up or down or in maintenance. And we have also alerting system, and we use Itzinga. Additionally, we also implemented a very complex monitoring in Grafana using Graphite and Prometheus. Here on the screen you can see some graphs we have. This is the view from production, by the way. And this is another dashboard, more detailed dashboard, which relates to resource usage. Okay, so what are the new requirements we currently have? So first of all, we definitely need to reduce operational costs, because even with all this automation, a lot of resources are spent on operations. Consequently, we can't deliver new features we would like to, and also we are not able to utilize our hardware to full capacity. This relates to the engineering. Engineers are focused on operations and not on delivering new features. And obviously then they are quite bored, and nothing is more dangerous. We also need better electricity. First of all, the data movement is needed when you need to scale up because data has to be rebalanced. We also would like to have simpler and faster scaling, and we would also like to get rid of multi-tenancy. Currently, we have to collocate many customers on the same cluster, and metadata catalog is growing and growing, so there are some limits, and we would like to isolate customers in a better way. Then we also need to handle small customers in a better way. This relates especially to small regions. Well, for example, when we would like to deliver our platform to Australia, for example, it's quite a small region. There is only one customer, and deploying new data center and new deployment scripts is very expensive, and it needs a lot of time. Okay, so what are desired features related to those new requirements? So first of all, we need as simple as possible deployment and also flexible deployment. So we basically want no dependency on infrastructure, specifically on hardware, virtualization, or operating system. Ideally, we would like to have declarative deployment. It should be simple and efficient, so basically by executing one command or by single click, it should be deployed very quickly, and it should be resilient deployment and any additional update. That means that we will be sustainable, so the cost of operation doesn't grow significantly with number of databases. Regarding elasticity, we definitely want to separate compute from storage because we have many customers who need huge compute, and we, on the other hand, have many customers who have a lot of storage, but they execute some queries only rarely. We would like to scale a running database up and down seamlessly, both on demand and automatically, and ideally we should be able to define auto-scaling. And everything this should happen zero downtime. And as an edge case, we would like to scale to zero or from zero, which means to hibernate or revive the database, and while hibernating, release the resources to other applications. Regarding resilience, we need zero downtime plant maintenances because hardware and operating system upgrades are needed more and more often from security reasons, or even because we want to provide better performance with better hardware. We also want seamless Vertica node recovery, so it should be auto-restarted, auto-evacuated from failed hardware, and so on. And no SQL query should fail during any plant maintenance. And last but not least, communication between database and separated storage should be without any interruptions. Okay, so now I'm going to demonstrate you the existing solution. So main components we used Docker to prepare an image of Vertica, and we decided to use Kubernetes to orchestrate containers. Additionally, because the orchestration of stateful applications is not easy in Kubernetes, we decided to use Operator SDK to implement Vertica operator. And last but not least, we also need to have some S3-like storage, and we decided to use mini-IO storage because it can be deployed in Kubernetes as well. So what is Kubernetes? So the Kubernetes is a container orchestrator. It can orchestrate containers across multiple hosts. It provides automated deployment. So it controls and automates application deployments and updates in a declarative way. And you can rely on identical services are everywhere. It optimizes resource utilization. So you can schedule applications on hosts, and they can share the resources, and you can define various rules related to resource consumption. It also provides storage, so you can mount storage, remote storage, and dedicate it to stateful applications. Then it provides scalers, so you can auto-scale the applications. It automates operations, so there are some health check and self-healing processes and so on. And last but not least, it's easy to extend. So you can define your custom objects and deploy them into Kubernetes. And this is exactly what we need here. Okay, so this is high-level solution schema. You can see here 3 components: Vertica operator, Vertica containers, and S3 storage. Vertica operator is responsible for managing Vertica containers. It can also prepare some things in S3 storage, which are required by Vertica database. And then Vertica containers are using the S3 storage. Vertica Docker image consists of base operating system. There must be SSH server because Vertica uses it to communicate between nodes. Then obviously there must be Vertica itself. Python also must be there because we are going to use libraries, Python libraries, to communicate with S3 storage, with Vertica, and that's it. And there is also entry point scripts, with some additional logic. Vertica operator, managing Vertica. It again contains some base operating system and Python. And then we decided to use COP framework, which is provided by Zalando company. It implements operator SDK paradigm, and because it's in Python, it's very easy to implement it, to utilize it, and extend it. And again, in the operator, we need libraries for communication with S3, with Vertica, and additionally also with Kubernetes API, because we are going to manage Kubernetes objects. Okay, so how it looks like in Kubernetes end-to-end. Kubernetes provides so-called custom resource definitions. So we can define custom resource definition for Vertica, custom object, and we can define our own custom properties like number of replicas, shard count, S3 location, and so on. Then, based on this custom definition, we can create Vertica custom object, which relates to certain Vertica cluster. So this particular cluster will have 4 nodes with 8 shards, and so on. Once this object is created, event is sent to Vertica operator, and Vertica operator is responsible for managing Vertica containers. So when a custom object is created, operator creates a database. When custom object is updated, it can mean that existing cluster should be scaled up, for example. And the storage behaves very similarly. Minayo provides also the operator. So there is custom resource definition for Minayo. You can create Minayo custom object, and then Minayo cluster is deployed. Here are key principles for containers and operators. The container entry point must handle all processes. Yeah, that's by design. And because in case of Vertica, there are more processes running, not only Vertica, but also SSH server, we need to handle them all from one single point. And that's why we decided to use so-called supervised D, which can be used in this case. The second key principle is basically Kubernetes API. You can face the timeouts when you call Kubernetes API, so long-running calls against Kubernetes API is not a good practice. And that's why we decided to use the design when you initiate an operation and then you poll for result. And the last third principle is relates to operator resiliency. Anytime anything fails, you need to be able to restart the process and finish it finally, and that's why every step in the operator should be idempotent. And this is the current architecture schema. It's, let's say, MVP. In our case, we need to use kubectl statement from command line. We can deploy Vertica custom object, and then everything is in hands of Kubernetes Vertica operator. So the Kubernetes Vertica operator is responsible for creating stateful set with all the pods, and then it's responsible for managing Vertica cluster itself. Vertica clusters are using Minio clusters, and Minio operator is there as well. Also, you can see here the connection between operator and S3 storage. This is because we decided to persist state of any operation into Minio, because this Minio is the only persistent storage here. So we persist their state of, for example, creation of the database, which can consist of many steps, and we can save there in which step we are, for example. Okay, here you can see some detailed solution design of create database flow. You can see here the creation of Vertica object as a first step. And once the object is created, the operator is creating stateful set. Then it's waiting for all pods are running and they have all IP addresses. Then admin tools conf is created and backed up to S3. And then the database can be created through, for example, first pod. And once create database finishes successfully, the result OK is returned. Okay, specifically there are some special scenarios we have to handle. The first one is so-called re-IP. Vertica uses IP addresses only, and because containers can be recreated quite often, IP address can change. And the operator must watch pod create events, and this situation must be handled accordingly. So the IP address must be changed both in admin tools conf and in database itself. The second scenario, which also works currently, is hibernate and revive. Basically, by changing custom property of Vertica custom object, the property name is state, and you can change it from up to down and from down to up. And by doing this, you either hibernate the database or revive it. When the database is hibernated, all the resources are released. So the stateful set is deleted, and Kubernetes worker nodes can be used by other applications. And next scenario is scaling. As of now, we are capable to add and remove nodes by updating number of replicas in custom objects. Nodes are added or removed from or to existing cluster. And we also played a little with Kubernetes autoscaler. Here you can see the design schema. Basically based on default Kubernetes monitoring, which contains information about CPU and memory utilization, for example. You can create autoscaler object in Kubernetes, and you can define minimal and maximal number of replicas. and then autoscaler based on the monitoring can scale the existing custom object. So basically it updates number of replicas in custom object, and then a Vertica operator is triggered and it adds node to existing cluster. Okay, so now it's time for the demo. Okay, so I prepared several scenarios related to Vertica running in Kubernetes, and then I also prepared some small surprise in the end. So I'm going to use K9S tool, the command line tool for managing Kubernetes cluster. This is our testing Kubernetes cluster in Amazon Cloud. You can see many namespaces here, but the important one for this demonstration are Minio and Vertica namespaces. So let's start with Minio namespace. You can see here the operator and also 4-node Minio cluster. I think nothing else is now important. So let's switch to Vertica namespace. You can see many pods here. That's because I deployed our new GoodData platform here as well. But now let's focus on Vertica. So you can see Vertica operator here. And I have already deployed 3-node cluster here because it takes some time exceeding this presentation. Let's look into the log of Kubernetes operator. Oh, there is nothing. Somebody deleted my logs. Never mind. Let's start with the first scenario, and let's delete one node, one Vertica node, one Kubernetes pod. When I delete it, because it's covered by Kubernetes stateful set, the node, the pod should be immediately recreated, but it's empty. And because it's empty, it cannot join the rest of the cluster. And that's the situation when a Kubernetes operator, Vertica operator, has to handle this situation. So let's examine the log. Oh, somebody deleted it to me. Oh, sorry. This is unintentional. Okay. I also prepared the video exactly for this situation. Do we have time to switch to video page?
Yes, go right ahead. It's just a recorded version of the same video, just in case something technical goes wrong, because you know how that works with live demo.
Oh, okay. So this is the video. Sorry, somebody disrupted my deployment because it's our testing Kubernetes cluster. So my apologize. So let's look. Let's go through the same scenario in video. So you can see here again all the namespaces in Amazon Cloud. Now I will be talking about Minio cluster. This is something what I have already described. What I can see here more is you can also extend existing Minio cluster. It's recently they added this support. So once you are running out of space in Minio, which can happen when your customer is growing significantly, then now it can be solved. Yeah. Here I should go to the Vertica operator log. In a while. Yes. Yeah. So here you can see the log of creation of the cluster. Yeah. So first of all, there is a rich debug. All the properties of Vertica custom objects are printed, are logged to the screen. Then you can see that the stateful set was created with 3 replicas using Vertica image, which is stored in our repository in Amazon. And then we were waiting for all pods are running and they have IP addresses. With those IP addresses, operator prepares admin tools conf, and it uploads this admin tools conf to S3 storage, and then it downloads it to all pods. Finally, we initiated creation of the database, and we were polling for the result. You can see that after 80 seconds, all 3 nodes were up, and then creation of the database was finishing, and together it took around 160 seconds to create the cluster. Yeah, now you can see how I'm deleting the pod. The pod is recreated immediately by the stateful set, as I have already mentioned. And now we should go to the log of Vertica operator, and we should review what's happening. Yeah, so here you can see that creation of the pod initiated Vertica operator task called re-IP. We detected that the new pod, Vertica EON AWS2, was created. We are polling for new IP address, and we realized that the IP address is different. And now admin tools, the new admin tools conf has to be generated and uploaded to all pods. And then we can start Vertica node on the recreated pod and wait for the node to be up and running. The polling for Vertica is managed remotely from the operator by basically selecting from some system table. So once this select succeeded, we can be sure that Vertica node is running there. And you can see that it took circa 60 seconds to finish this recreation. If I would drain the Kubernetes worker, the stateful set would create the pod on different Kubernetes workers, so I could evacuate the Vertica node to different hardware nodes, even, for example. And here you can see that all nodes are running in VSQL, and the third node has the new IP address. All right. The second scenario I prepared here is scaling the cluster up. So what I need to do now is I need to edit the custom object. Specifically, this is the definition of custom objects. You can see now on the screen. And what I need to do is I need to edit a number of replicas in this custom object. So I edit it from 3 to 4. I save it. This obviously can be also deployed from some delivery pipeline, the update of the custom object. And now let's review the Vertica cluster. What will happen? You can see that the fourth Vertica node was created, or the Kubernetes pod. And in the log of Vertica operator, you can see that the scaling up operation was executed. We are again waiting for the new pod to be started. We collect its IP address, we extend admin to conf accordingly, and then we can execute db add node operation, in this case through the pod number 0. And once the db add node is will finish, we should see all 4 nodes are up and running. Okay, but this takes some time, so let's now switch to the surprise scenario I promised in the beginning. Now I should switch to my browser in a while, hopefully. Yeah. Okay, so what you can see here is our new GoodData platform called Anywhere. I deployed and on a dedicated DNS, dedicated hostname Vertica Anywhere GoodData.com, and in the root folder you can see the documentation related to the deployment. You can integrate the platform with any database. In our case, I integrated with the Vertica running in Kubernetes. And once it's integrated, we can scan the database, the integrated data source, and create logical data model. Yeah, so here you can see some options how you can scan the physical database. I don't need to customize it in any way because it's most simple tutorial, this scenario. You can see some model with quite beautified logical names. What happened here is that I scanned physical model and based on data types, naming conventions, and referential integrity, I was capable to detect all data sets, all analytical, all logical entities, and references between data sets. So now I published the logical model, and I can go directly to our application called Analytical Designer. On the left side, you can see so-called catalog, which contains the logical entities we have just published as a part of the logical data model. And I can now easily drag and drop the logical entities into the right side, into visualization side. So for example, I can zoom quantities, order lines quantities. I can choose for tree map visualization type, and I can view those quantities by category, product category, and by product name. And now I can save the visualization and I can share it with other users, or I can embed it into some dashboard, or even I can embed it into a React application. So isn't it easy onboarding? What do you think? In a few seconds, we went from the database to such a nice visualization.
I think it's pretty awesome. I'm not sure my opinion is worth a lot in this situation, but that's pretty amazing.
Okay. Okay, so in the end, let's review if scaling the cluster up succeeded. And in the log of the operator, we can see that the cluster was successfully resized from 3 to 4 nodes. and it took 80 seconds. It's quite fast. On the other hand, it could be even faster. I'm pretty sure that in the future we will add support for subclusters, secondary subclusters, and then the scaling up will be significantly faster. And here you can see that the cluster has 4 nodes and all nodes are up. All right, so that was the live demo. Okay, so I have a few additional slides related to the future. So let's go quickly through those slides. The immediate next steps are, I think, obvious. So we need to improve idempotency of the operator, so it's really production ready. We definitely need to add unit and integration tests, implement delivery pipeline, and definitely we need to manage performance tests to be sure that there is no performance degradation related to the deployment into the Kubernetes. And once everything this is done, we can go to production and start with small or mid-sized customers. Some more details about tests. We plan to utilize K3S ecosystem. With this ecosystem, I think that it's provided by Rancher company. You can deploy Kubernetes even on your laptop, and it can be even multi-node clusters. So you can test all operator use cases, and even you can test all maintenance use cases related to Kubernetes, like, for example, evacuation of some failed worker node. Regarding delivery pipeline, we have 2 options here. We have Jenkins pipelines and also GitLab pipelines for the current GoodData platform and for the new data platform. We definitely want to deliver continuously, so we have to provide all the integration tests, and we definitely want to have an ability to define the configs hierarchy. We need hierarchical config. So basically, for all the clusters in the same range, for example, you have some shared properties, and you don't need to define them multiple times. Regarding new features, so definitely we want to utilize subclusters, and it shouldn't be too complicated to do it. We want to be able to schedule, hibernate, and revive, and we would even want to test if revive could be triggered even by executed query. We have to implement liveness and readiness probes, so Kubernetes knows if Vertica node is up or down, or in maintenance state, for example, and behave accordingly. We have to support Vertica upgrades, obviously. For now, we are okay to support downtime upgrades. We also are thinking if it would be valuable to revive from template instead of using create database operation. And last but not least, we would like to optimize size of Vertica image. Example, it could be based on some minimalistic operating system like Alpine or UBI, and we can also reduce the size of Vertica RPM itself. Regarding balancing and routing, I think this is not necessary currently because we want to deploy all stateful and stateless applications into Kubernetes. But if in the future we would like to expose outside Kubernetes Vertica cluster, we can use ingress routing rules, and also we have experiences with external DNS already. And last but not least, we should also utilize service discovery. And this is the final future architecture schema. Here you can see the delivery pipeline, a scheduler for hibernating and reviving, You can see Vertica custom objects for multiple subclusters. You can see monitoring here and autoscaler. Based on the monitoring, metrics are pushed from Vertica nodes to monitoring, and you can also see the exposure outside the Kubernetes using engines, ingress, external DNS, and so on. Okay, and because this is a huge task, we would like to collaborate in this area with Vertica. So we would appreciate if Vertica tooling is more ready for immutability in Kubernetes. We would like to speed up DB operations, like creation of the database, scaling, hibernating, and so on. It would be also great to improve resiliency of the EON mode. We, in GoodData, already implemented so-called offload mode. So instead of select statements, selects are exported into Parquet, into S3 storage. And when select fails, you can retry the export and user doesn't notice. Automatic query restarts could be also improved. We would like also to have more the support of more S3 storage locations. So we would be able to move historical data to different S3 storage, running on top of, for example, much cheaper hardware to save some costs. And recently, we also started a discussion about our new platform, GoodData Anywhere. And we are now talking about to prepare an image of GoodData Anywhere containing also Vertica. In the beginning, we would like to start with free community edition of Vertica. GoodData Anywhere will be for free in the beginning as well. It should be easy to onboard, just like I demonstrated. So there should be preloaded data, tutorials, documentation, and so on. And additionally, we are also talking about utilization of advanced analytical capabilities of Vertica. So, namely, we are talking about machine learning, geospatial, and time series. And it should be downloaded easily from basically anywhere. And then we should be observing adoption of our solution.
Awesome.
And that's all from me.
Thanks, Jan.
Thank you for listening.
We had a ton of questions come in, so I'm going to try and see if I can squeeze a few in because our time got short because the demo had to be restarted essentially. Someone mentioned that your slides were funny, so I just thought I'd let you know that. There was a couple of questions about performance. An impact of using the additional Kubernetes later. What's your estimated performance impact, or are you afraid that it's going to cause a performance degradation?
Yes, yeah, this is a great question. Obviously, we can expect some minor performance degradation related to additional layer, the Kubernetes layer. We have already tested mini-IO storage running natively in Kubernetes, and we were quite surprised that the performance degradation is not that large. We expect the same in case of Vertica, and to be honest, I would be pretty okay with even, for example, 10% of degradation, because you can spend additional costs and deploy more hardware. But on the other hand, you can save a lot of costs related to operations and many other tasks. Yeah. So your engineers can do better. They can deliver new features, and they can bring additional value. Yeah. So and also the hardware and all complete infrastructure is performing better and better with new generations of hardware and network infrastructure. So I would be okay with the performance degradation unless it's significant.
Yeah, I think you already did some testing on that also. We don't want any bored engineers. That's always bad. Do you have any plans to open source your work?
I would like to discuss this topic with Vertica. I would be absolutely okay to open source it because it would be great if other companies would collaborate. I would like to discuss this also with Zalando company because we use their operator SDK framework. Yeah, I would be very happy if we could open source it. Just the management of open source community is resource demanding, so we need to discuss it also internally in the company. But yes, I would be very happy.
Awesome. All right. Are there any situations or use cases where Vertica and Kubernetes are not the best plan?
Great question. I think that we will see in the future. Yeah, I think that we should start with small and mid-sized customers, as I have already mentioned, for example, in small regions all over the world. And we will see in the future if this deployment is a good fit for largest customers with even tens or hundreds of petabytes of data. In this case, I would be absolutely okay to keep deployment in bare metal, for example. But for the small customers, and there are many such customers, I think it would be very beneficial to go this Kubernetes way.
Okay, so best for small customers starting out. How do you handle depot population when scaling the Vertica clusters up, when you add compute?
Wow, this is interesting question. So there is a possibility to pin into depot, and there is also a possibility to monitor the depot. Basically, we need to monitor it on production in larger scale. We need to improve then the monitoring, and then we will see. So as of now, we don't have best practices yet because we don't have as many deployments as we need to make a decision.
Okay. One of the questions was about whether or not this will work with Vertica 10 and EON Mode on a pure flash blade. And I think the answer is probably no, because Minio and Kubernetes work together. Is that correct?
Yes, I am aware of pure storage flash blade, and it's remote storage, enterprise storage, high-performing storage, and it can be running outside the Kubernetes, and you can run Vertica inside the Kubernetes, and there shouldn't be any problem to integrate them. So in such a scenario, the storage would be not immutable, running in Kubernetes, but in this case, Vertica would be sort of stateless, and the advantage of running it into Kubernetes and scaling it and operating it easily would be still there.
Interesting. Okay. Let's see. This is a question: how many nodes? How many pods? Main nodes and workers, I think, are required for a developer solution. I think there's maybe a misunderstanding that Vertica doesn't have main nodes and workers. There, all the nodes are kind of equal.
Yeah.
But does that just how many nodes are required for a good developer solution?
As far as I know, in Community Edition, you can have 3 nodes, and 3 nodes are absolutely okay for running. When you lose 1 node, the rest of the cluster is still running, and this is for free, up to 1 terabyte. And then you can deploy any number of nodes. Maybe there is some limit like 1,000, but I don't know about it.
Yeah, we've got some pretty huge clusters out there, but that's pretty accurate, I'd say. You can actually run Vertica in a single node, and that works.
Yeah.
But our free community edition goes up to 3. So, hey, when you're I don't know. I've got so many questions. I'm like trying to pick the ones that you can answer in a short amount of time. You know what? I think we're totally out of time, and I'm just going to have to cut it off. We are willing to see if we can tackle some of these questions on email since we've just run out of time. But I really appreciate you guys coming, and thanks so much, Jan. You really did an amazing thing. You had the courage to try to do a live demo, and then you still dropped back and punted and had a backup in case when you had some problems. So that's pretty amazing. So everybody who came, please leave us some feedback on the webinar. Let us know how we're doing and guide us in the future. And just a quick reminder, a replay of today's events and a PDF copy of the slides will be available on demand shortly. And of course, we invite you to share those with your colleague. Now, thank you guys so much for being a great audience today. I loved all the questions. I wish we had gotten to more of them, but we will follow up with you in email. This concludes our event. Have a great day.